we have a very interesting problem. What it says, a bee flies towards a burning candle and then turn away from it with a constant speed 12 centimeters per second on a parabolic path given by y equal x squared plus 3 in the given direction. So bee try to flies on a parabolic path, and then you can see that when it flies on a parabolic path, it can create two projections, one on the x-axis and the one on the y-axis. So asking what is the speed on the x projection when the b is at the point 14. So this problem, that's part A, and part B says at what point the projection on the x-axis moves fastest, and you will see that actually these projection move in different speeds. So asking at what point can I get faster. So and we'll see how we can solve that part. And then in part C, it's asking, assuming the candle is at the origin, find how fast the distance from the candle to the B changes when the B passes through the point mentioned in part A, that means the point 14. So let's try to answer this question one by one. So this question actually can be answered in multiple ways. I'm going to show you a technique that you may not have seen before. So let's see how we can do that. So let's let's do part A in a slightly different way. So what we're going to do, we're going to draw the tangent line at the point 14, and then we can draw this small triangle. So when you draw this triangle, what I'm going to do, I'm going to say take the length of the tangent part. I'm going to call this is ds, length of the tangent part, and then the length of the x part I'm going to call dx, length of the y direction I'm going to call dy. So this is the small triangle for the tangent. Now once you do it, um, by the Pythagorean identity, so by the Pythagorean identity, you can write like this. You can write ds squared equal dx squared plus dy squared. So these are like very small infinitesimal length. So you can write this using the Pythagorean identity. Now what we're going to do, we're going to divide both sides by dx squared. So we divide by dx squared, then you can write this one as ds over dx squared equal 1 plus dy over dx squared. So now what we can do is we can take the square root. So we can take the square root and write this one. So when you take the square root, and you can see it's going in the positive direction, so you don't get plus or minus, you only get a plus sign. So we can write this one as ds over dx equal, I'm going to exaggerate this one, positive 1 plus dy over dx squared square root. So now we have a relation. So only thing that we need to find is what is dy over dx. That is very easy to find because you know the equation y equal x squared plus 3. So take the derivative and we can find dy by dx. So let's do that. So we can say since y equal x squared plus 3, so we can write dy over dx equal 2x, and then what we can do, we can plug in that to the equation. So that means we can write this one ds over dx equal, so let's plug in. So it is 1 plus, and then you can write this one as 2x squared square root, so which is equals to 1 plus 4x squared square root. So now this is ds over dx. Actually what we need is dx over dt. So now this is the moment that we're going to use the chain rule here. So what we're going to do, we're going to multiply. This is a very interesting step. So because you can see that what we have is ds over dx. So to get dx over dt, what we're going to do, we're going to multiply this one by dx over dt. That's how we do. So we're going to multiply both sides, multiply both sides by dx over dt. So then what will happen, then we're going to get, so we get on this side, it's very interesting, it's going to be dx over dt, because you can write this one as ds over dx. By the chain rule, it is dx over dt. So you can see this interesting step. You're going to multiply by that. That means you're going to multiply this equation, because we know that ds over dx is 1 plus 4x squared square root. That is the ds over dx. So times dx over dt. And then you can see that we know this one, that's given, that's a 12. And then we know the x value. Only thing that we don't know is dx over dt. So you can find dx over dt from this equation. So that means dx over dt equal, so you can see you can divide, so you get 1 over 1 plus 4x squared square root ds over dt, and then you know that at 1 4, that's the point we are talking about, so you're going to plug in the values. So it is 1 over 1 plus 4, x is going to be 1, so 1 squared square root, and ds over dt is 12. So that means if you simplify, you're going to get 12 over square root 5. The unit is centimeters per second. So that is the projection. That's the speed of the x projection. And also you can see this is positive. That means move into the right direction. So and then moves to the, so x projection. So you can see x projection moves to the right, moves to right. Okay, so that's how you answer the first part of the question. So now we'll see how we can do this using a, like if you know a little bit of physics, we can actually do this problem in a slightly different way. And also, like if you need the dy over dt, what are you going to do? You're going to multiply the both sides by, because this time we multiply by dx over dt. If you need the dy over dt, what we can do, we're going to multiply this equation by dy over dt, both sides. Then you're going to get dy over dt. If you multiply by dx over dt, you get dx over dt. It's kind of interesting. So yep. So this is the interesting situation. So it's like a new approach. Like now, I don't think you had done something like this before. Okay. So let's see. Like if you know a little bit of physics, we can do this problem in a slightly different way. So let's see how we can do that now. So if you know a little bit of physics, what we can do is as before, we can still mark the velocity curve. So that's the velocity curve. This is along the tangent. Now what we're gonna do is we're gonna study the two components. So we call these are components. So there's a component on the x direction. There's a component on the y direction. So we're gonna look at those two now. So and then they are 90-degree, these components. And then we can see, so this is the v value, so this is v, which is equal 12, and then the two components, so you can have the two components. So there's a one component going in the x direction, that component is simply dx over dt now, and the component go in the y direction is dy over dt. So you can write those two different components of the velocity vector. Now what we're going to do is we can use a Pythagorean identity again. So use a Pythagorean identity by the Pythagorean identity. We can, as before, we can write this one like this. So we're going to say dx over dt squared plus dy over dt squared, because they are 90-degree, equals v squared. So we can write v is a constant, v square. So we can write it like that. So now what we need to do is we need to figure out, because we are looking for dx over dt, but we need to figure out what is that. So that's where we use the chain rule. So now we're going to say since y equal x squared plus 3, what we can do, we can differentiate this one. Differentiating with respect to time, with respect to t. So what will happen is we can write this one as dy over dt. By the chain rule, we can write this one as dy over dx first and then dx over dt. So this is a chain rule step. Dy over dx is very easy to find, which is 2x. Dx over dt is, we write it like that. So you can see this is the same thing we just did. Now what we can do, we're going to plug in that into the equation. So let's plug in this into the equation. So we can see by substituting. So by substituting, we're going to get dx over dt whole thing squared plus, as before, 2x dx over dt, that's the derivative we just took, squared equal this 12 squared, because we equal 12, that's given. Now we can factor, you can see you can factor dx over dt. So if you factor dx over dt squared, you're going to get the factor 1 plus 4x squared, which is equals to 144. Now we can see we can just solve. So you can write this one as dx over dt equal as before. So you can write as taking the derivative, taking the square root, you can this one as 12 over 1 plus 4x squared by taking the derivative. And we assume, we know that this is positive, is going to the right direction. Okay, so and then what we're going to do is just evaluate at, so you can say at the 0.14, you can write this one as dx over dt. If it's a proper notation, evaluate at 1,4. So you're going to plug in the x coordinate. So it is 12 over 1 plus 4, 1 squared, square root, and simplify, you're going to get 12 over square root 5 as before, and then you don't forget the unit. So it is cms minus 1. Okay, so this is like a more physics approach, but you can use anything that you want. But you can see this is slide difference. The first one is like simply mathematical approach, we just use the small triangle from the tangent, and then the second one we kind of use a little bit of physics. Okay, so let's try to move on to the second part, part B. So part B is asking at what point the projection on the x-axis moves fastest. And you can see, if you look at the equation that we just derived, so we got that dx over dt is equals to 1 over 1 plus 4x squared square root times ds over dt. That's the equation we just derived. And then we know that this is a constant. This part is a constant. So if this part is a constant, and you can clearly see that so dx over dt is simply proportional to 1 over 1 plus 4x squared. So that means when the term on the right side, when this term gets large, dx over dt get large. When this term gets smaller, dx over dt get smaller. Since x is in the denominator, to get the largest value, so you can see that you need to find the smallest x value. To get the largest value, you need to find the smallest x value, because the x is in the denominator. So let's write it. So you can see that dx over dt, so we can write the argument here. So it's very clear from this equation. Dx over dt becomes a maximum when 1 plus 4x squared becomes a minimum, because it is in the denominator. That happens when, so you can see that happens when you can see 4x equals to 0, because there's a square, there's a plus sign, so that's why this happened. So that is when x equal 0. So that's happened when x equals 0. So then you can say that at the point 0, 3, the x projection moves fastest. So that means at the center, it moves really fast. So you can actually see this in animation. So let's see actually what will happen if you try to animate this one. We can see the bee's movement as an animation. As you can see, the x projection will start with a smaller velocity first, a smaller speed, and then when x get closer to, when x becomes 0, you can see it's going to speed up. So x equals 0 is going to speed up, and then it's going to slow down again. So this actually mimic the reality. For example, let's say like a bird try to attack you, and then if you try to chase it away, what will happen? It's gonna turn with the same speed. But if you look at the x projection, and you can see it's gonna have like a similar pattern. It's gonna start with a smaller value, and it gets larger and larger at the center, and then it's gonna slow down. Yeah, so it's like a very interesting phenomenon. And then this animation was done using a Desmos, and you can find the link in the description. So let's move on to the next part. So let's do part C now. So what it says that assuming the candle is at the origin, find how fast the distance from the candle to B changes when the B passes the point mentioned in part A. That means the point 14. So let's draw the situation. So B moving on the parabolic path. So we can pick the point. So it is point 14. So that's the point. So what we can do we're gonna take that distance. So that's the so there's a candle here. So we can take the distance from the point to the candle. Let's call this is L. This distance is L. So if this distance is L, what we can do is we can look at the general x and y coordinate. So this is the x coordinate and this is the y coordinate. So we pick a general point. So what we normally do is we pick a general point and then plug in the value, because if you just use the static point, then you can't take derivatives because these are constants. So we pick a general point and then plug in the value. So now what we can do is we know this is like 90 degree. We can use the Pythagorean identity now. So let's say, so by the Pythagorean identity, so you can write this one as L squared length squared equal x squared plus y squared, that directly from the Pythagorean identity. Now what we can do, we can differentiate this one with respect to time, because you can see all those variables change with respect to time. So they are function of time. So we take derivative with respect to time. So you're going to get from the first term you will get 2L dl over dt. Second term you get 2x dx over dt. The third term you get 2y dy over dt. So you can cancel 2 and then solve for dl over dt. That's what we are looking for. So if you solve for that, you're going to get dl over dt, which is equals to, this is like a very common problem. We have done many problems like that. So, and then this is y dy over dt, divided by L. And you can see most of those terms actually we know what is x, we know what is dx over dt, we found that, and then we know y, and dy over dt also we can find this because like when we try to do the previous problem, we actually try to derive what is dy over dt, which is 2x times dx over dt. Or like if you want to do this as a general one problem, like a single problem, then you can actually derive this one using the chain rule, and then we need to find L2. So let's try to find those things and then you plug in here and then you can get the answer. So let's try to find those missing terms now. So we can say at 1, 4, at 1 4, you can see that L squared equal X is 1 squared, Y is 4 squared, which is 17. So L equal square root 17, and which is positive. So that's the L value. What else we need to find? We already know what is dx over dt. We only need to find dy over dt, and then as before, you can see. So I'm going to do this as like a general problem without using what we did. So we have this, and then what we can see again differentiating with respect to time. So you can write this one as dy over dt equal 2x dx over dt, and then we know this value. So 2 times, which is x is 1, dy over dt, we already found that was 12 over square root 5 from part A. And then when you simplify, you get 24 over square root 5, and then we can see we found all of the terms that now we can gonna plug in. So then you can write, you can say dl over dt, that's what we are looking for. So let's try the formula. So now what we're going to do, we're going to plug in here. So let's plug in all the values that we know. X equal 1, and then dx over dt is square root 12 over 12 over square root 5, y equal 4, and then dy over dt was 24 over square root 5, and then L is square root 17. And you can see that you can take square root 12 or 5, that's like a common factor. So if you pull it out, you can write this one as, you can see 2 times 4 is 8. So there's like, you can write this one as 12 times 2. So then you can multiply these two, you get 8 plus 1, so 9. So you can write this one as 9 times 12 over, you can say square root 5 times square root 17. So if you simplify, you're going to get 108 divided by square root 85. So this is centimeters per second. So that is the speed that the length, the distance between the candle and the bee changes. So it's like very interesting problem. It's a lengthy problem because like 3 parts. So it's like a very interesting problem, and we solve this in like a different way than the normal way. We use a regular calculus approach, and then we also use the physics approach. So thank you for watching.